Section 3.3 is about graphing systems of inequalities. So we need to know what part of the graph represents the solution or solutions to a system of inequality. So you guys practiced graphing inequalities in the last chapter. So we're just going to basically apply that knowledge to systems. So we're going to have more than one inequality to graph. So the solution to a system of inequalities is an ordered pair xy that satisfies both inequalities in a system. So it's just like the solution to a regular system of equations. You have a solution that you can plug in, but with inequalities we know we have multiple solutions. So there are lots of things that we could plug in for x and y and satisfy both equations or inequalities. So we want to know, is 5, negative 2 a solution to this system of inequalities? So how would we figure that out? Well, if we look at 5, negative 2, then that represents our x and our y. So I can plug in 5, negative 2 for both x and y and see if this works for both inequalities. So let's try that. So if I have negative 5 plus negative 2 is less than or equal to 8, then I would get negative 7 is less than or equal to 8, and that is true. And then I have 4 times 5 minus negative 2 is greater than 6. Well, when I have minus and negative, I know that that makes a positive. So that's going to turn into addition. And so I'm going to get 20 plus 2, so that would be 22 is greater than 6, which is also true. So that means that 5, negative 2 is a solution to this system of inequalities because when I plugged it back in, it worked. Now there are multiple things that I could plug in for x and y because these are inequalities and it would work. So inequalities have many, many, many solutions. Okay, so let's practice graphing a system of inequalities. So let's say I have this system right here. So what I need to do is I'm going to graph each inequality separately, but I'm going to put them on the same graph. So first, I have the inequality y is greater than negative 2x plus 5. So if I do that, my y-intercept would be negative 5. So I would go down to here. My slope would be a negative 2, so I would go down to right 1, down to right 1, and I can continue my pattern this way. Now, when I'm graphing inequalities, there are two things that I need to remember. If I look at my symbol, that tells me two things. It says greater than, so is my line going to be dotted or solid? So because it does not have the equal to underneath, I know that this is going to be a dotted line. So here's my dotted line. Okay, and then because it says greater than, I'm going to shade above the line. Oops, I forgot to change my colors. So I'm going to shade above the line because it says greater than. Okay, now I have another system of inequalities. So this is what I propose that you do. You can either get two colors so that you can see like how they overlap, or when you shade, just shade really, really lightly, and then when you see where the two equations, the shading will overlap, shade that part in really dark. So for the second one here, I'm going to use red. Okay, so I have y is less than or equal to x plus 3. So my y-intercept is 3, and my slope is 1, so I go up 1, right 1. And then I'm going to draw my line. And again, I have to decide if it's going to be a dotted or a solid line. And it is going to be solid because I have the equal to underneath. Then I have to decide where to shade. So because the symbol is less than or equal to, then we are going to shade below our line. So we're going to shade below right here. So the system of inequalities shows the solutions by the place where both parts overlap. So if I take a look at my graph, where do I see both red and blue shading? Well, I see it right here in this section. So that section would contain the solutions to my system. Now remember, the dotted line represents no solutions can fall on that line, and the solid line represents that solutions can be on that line. So any points that are on the solid line are solutions, but the ones that are on this dotted line are not solutions. And then any one that is in this shading area where the two shading overlap, that would be where solutions lie also. Now let me erase this really quick so I can show you something. Now these were our two lines. And remember, our first line we shaded above the line. So this is just another way that you can do this if you don't like the way that that was laid out for you before. So let's say that I was supposed to shade above this line first. So a lot of people draw arrows going this way so that they know which direction the shading's going. Okay, and then for this other one, we were shading below. So the part where they're going to overlap is in this section right here. And so then people color that in. So you can also represent it that way. If that was easier for you, then you can draw arrows in the direction that they're supposed to be shaded, and then you can find where they overlap and shade that in there. Okay? So, or you could just shade really lightly in this area and really lightly in this area, and then where they overlap, you could shade darker. So there are three different options that you could do for the shading. So to go back over our steps, first we graphed the first inequality, and we had to decide if the line was dotted or solid, and then we had to decide if we needed to shade above or below the line. And then we repeated this process for the second. There's a typo there. It should say second. Change that. So the second inequality, and then the part where the shading overlaps contained the solutions to our system. Okay, now, what about system of inequalities that have no solution? So when the shaded regions don't overlap, then there's no solution to the system, because if the shadings never overlap, then you can have solutions for one equation or inequality and for the other inequality, but not for both together at the same time. So let's graph this inequality and see how that looks. So I have 2x plus 3y is less than 6. Well, I can't graph that right now as it is, so I need to solve for y. So I'm going to subtract 2x and solve for y. So I get 3y is less than negative 2x plus 6. So I need to divide by 3. So I get y is less than negative 2/3 x plus 2. So if I graph that, then my y-intercept would be 2, and my slope would be negative 2/3. So I would go down to right 3, down to right 3, down to right 3. And then I could continue my pattern going this way as well. And then if I look at my symbol, it says less than. So I'm going to have a dotted line. So I'm going to grab my line tools, and I'll make this one dotted. So this line is dotted. And then I'm going to shade below because it says less than. So remember, you could do this thing. Oh, you could do this thing where you draw the arrows to show which way you're supposed to shade, or you can just go ahead and shade it in. And then we would graph the second one. So the second one shows my y-intercept is 4, and I'll use red for this one. Y-intercept is 4, 1, 2, 3, 4. And my slope is negative 2/3 again. Down 2 over 3, down 2 over 3, down 2 over 3. And so I'm going to grab my line, and this time it's going to be a solid line. Oops. Solid line between my points. And it is greater than, so I'm going to shade above the line. So I would shade in this direction. So if you look, this shading and this shading, they do not overlap. So there would be no solution to this system of equations. Now let's try graphing some systems with absolute value inequalities. Now this is different. Okay, you guys should remember how to graph absolute value equations because we did this in the last chapter. But in case you need a refresher, we're going to do it again. Okay, so first I'm going to graph the line y is less than or equal to 3. So because there's no x, what kind of line is that? Well, it would be horizontal. So I'm going to go to y equals 3, and it's going to be a horizontal line. And I look and my line is solid. So I'm going to go ahead and grab a solid blue line. And I'm supposed to shade, and it says below because it's less than. So I'm going to shade below the line. Okay. Then I have y is greater than the absolute value of x plus 4. So absolute value makes what shape on the graph? Well, if you remember, it makes a V shape. And this plus 4 inside the symbols means that it goes left 4. So I'm going to go left 4, 1, 2, 3, 4, and that's where I would make my V, and there's a slope of 1. So I would go up 1, right 1. And so from here, I need to decide if my line on my V is going to be dotted or solid. And since it is just greater than, and it doesn't have the equal to sign underneath, it is going to be a dotted line. So I'm going to have a dotted line here and here. And I probably should change those so that they are just ends on one side. There we go. And so then I have to decide if I'm supposed to shade above or below. Well, this says greater than, so I would shade above, which would be inside the V. So if you look, the point where they would overlap would be in this section right here. That's where the red and the blue would overlap. So you can do it like that, or if you prefer to shade both colors the other way, remember for this one we shaded below, so it'd be like this. And for the other one I shaded above, so it'd be like this. So this little section right here is where the red and the blue would overlap. Okay? Alright, one last thing. Sometimes systems contain more than two inequalities. And so you can have three or more. Now, this can be very confusing if you do the shading in different colors. You can use three different colors, that might be helpful. Or you could just shade lightly, but it's still really hard to tell when there's three or more where the shading overlaps. So I like to do the arrow system for these. So at first I'm going to graph y is less than x. So I'm going to use red for this. So I have a y-intercept of 0 because there's no number on the end. And my slope would be a 1. So I go up 1 over 1. And my line would be dotted because there's no equal to sign underneath. Okay. And then I would shade below the line. So I'm just going to draw arrows indicating which way I'm shading. That way it's easier to see where they overlap. Then I have the inequality y is greater than or equal to -3. So I'm going to do this one in blue. So there's no x, which means it's a horizontal line. So I go down to -3. And then I'm going to um, check to see if I'm going to have a dotted or solid line. So I'm going to have a solid line. Because it had the equal to sign underneath. And then I'm going to indicate where I'm shading, and it says greater than, so I would shade above. Okay, and then the last line I have is x is less than 5. So if I go to that, x is less than 5, this has no y. So in this case, it would be a vertical line. I'm going to use green for this one. So 1, 2, 3, 4, 5, and it would be a vertical line, and it's going to be dotted because there's no equal to sign underneath. So it'll be like this. Whoops. Make that a little bit over. And then I have to indicate which way to shade. Well, it says less than, so all the numbers less than 5 would be to the left. So I would have all of these going to the left. So now you can kind of see where the red, the blue, and the green are going to overlap, which is just in this triangle section right here. So again, I think it's easier to use the arrow method on this one just because it's so hard to tell, but you can use, if you use three colors, it makes it easy, but if you just have like one pencil, it's kind of hard to tell where they overlap. So I would shade really lightly and then shade really dark where they all overlap. So if you use the three different colors, it would look something like this. It would go here for the green, and then the red was below. So it'd be like that. And then the blue was um, above, so it'd be like this. So the area where the red, the green, and the blue are in this section right here, you see how it can get really messy. So I like the arrow method for those. Now don't forget to write your summary and also to go back and to chunk your notes and write questions. Thank you.